So this example shows us that all of our object references have both a declared type and an actual type. So the declared type is the type we specify in the declaration. So for this little example here, E1, E2, and E3, the declared type is all employee, but the actual type is specified by what we instantiate the object as, so basically which constructor we call. So E1, even though the declared type is employee, the actual type is salaried paid employee. And for E2, even though the declared type is employee, the actual type is hourly paid employee. And for E3, the declared type is employee, but the actual type is unpaid employee. So all of our objects are specified by both a declared type and an actual type. Now the compiler uses the declared type. It only knows the declared type. You can think about the compiler as sort of having very narrow vision, being very rigid, and just saying, all I know is the declared type, all I care about is the declared type, and all I am enforcing is the declared type. So the compiler uses that declared type to decide what you are and are not allowed to invoke. So for these three references, because the declared type is employee, that means that you are only allowed to invoke methods that exist in the employee class. So the compiler doesn't care what the actual type is. It might not even know what the actual type is. All it cares about is the declared type, and it will insist that you only invoke methods that are defined in the declared class. That was why we can't invoke vacation on E1, because even though vacation exists in salaried paid employee, it does not exist in employee. And again, all the compiler cares about is whether that method exists in the declared class. So that's one component that you need to know about how the object references work. The declared type governs what you are and are not allowed to invoke. But the actual type is what's figured out at runtime by the JVM, the Java Virtual Machine. And the JVM uses the actual type to figure out which version of a method is really invoked at runtime. So the JVM you can think about as a little more sort of fluid, a little more loosey-goosey, and the JVM says, well, I don't really care about what the declared type is. The compiler cares about that. I care about the real type. Tell me what kind of object this really is, and then let me use that to figure out which version of the method to invoke. So hey, okay, E1 is declared as an employee, but what type of object is it really? Well, it's really, the actual type is a salaried paid employee. So I'm going to invoke the pay method from that class. And E2 is really an hourly paid employee, so I'm going to invoke the pay method from that class. And similar for E3. So we're only allowed to invoke pay because it exists in employee, but that doesn't mean that that's the version that gets called. The version that gets called depends on the actual type. And the JVM will basically go as specific as it can. So if the pay method exists in this actual class, that's the version that gets executed. If for some reason the method did not exist in this class, it would go one step up the hierarchy and see if it's there, and if so, invoke that version. If it didn't exist there, it would go one step further, and so on and so on. It knows it's going to find it somewhere because it knows that at the very least it exists in this class, because that's the only reason we were allowed to compile. So the virtual machine, the Java virtual machine, kind of starts at that most specific class, the actual class, and looks for the method there. And if the method's there, that's what it executes. Okay? And that is polymorphism. It means that if we have an employee object and we invoke the pay method, it might be different versions of that pay method being executed depending on the actual type of the object. So an employee object, an object declared as an employee type, .pay, it's not always going to execute the same way. It depends on the actual type. And the fact that that runtime behavior can differ, that's what's polymorphism. That's what can have many forms. An employee object reference can have many forms. It could be a salary employee, it could be an hourly employee, it could be an unpaid employee. It can have different forms. And the right version of the method will be invoked depending on the actual type of that object. So again, we can declare objects to be of a type high up on the tree. That's where we can declare them. and then we can instantiate them anywhere lower on the tree. So any compatible type means anything lower in the hierarchy. And that declaration defines what we're allowed to invoke, but that actual type, that instantiation, defines which version is executed. So let's look at another example of this. So we're going to use the music store, the audio item files, and we're actually going to look at an example where not only does the compiler not care about the actual type, it actually doesn't even know the actual type, because we're going to ask the user to define the actual type. So at compile time, compiler is not even going to know, because it could be different when you run the program one time with one user input versus another. So let's look at these classes. So these were our audio item classes. An audio item is described by a title, a price, and a duration. That was our parent class. We have two child classes, audio music item. An audio music item is an audio item. And we additionally specify in addition to the title, price, and duration, we specify an artist and a genre. We also have a child class audio book item. So in addition to being described by a title, price, and duration, a book item is also described by an author and a number of chapters. Now we included all of our standard components, our getters and setters, and toString, but we also included a method called playSample. So in our audio item class, we just print out that we're playing 5 seconds of the audio item. In audio music item, we overrode that method to say, well, for a song, let's actually play a little more. Let's play 30 seconds. So we're going to play 30 seconds for our sample. And for a book, we kind of changed the method even more. We overrode it to say, well, we're actually just going to sample one chapter. That's how we would sample an audio book. Okay, so this playSample method exists in audio item, but it's overridden in audio music item and audio book item. So this is what my driver program looks like. I just have an output to my user, and then I ask the user to enter in the title, the price, and the duration. Now we could use the next double and next int methods of the scanner class, but instead I chose to just continue to use next line, which reads in a string, and then convert that string from a string to a double or an int using the double.parseDouble or the integer.parseInt. And again, what this does is it converts the, for example, string 180 that the user might type in to the number, the primitive value 180. These parsing methods are great for interacting with the user because although in the scanner class we have the option of using nextInt or nextDouble, in other types of user interactions we might not have that choice. We might only ever be able to read anything in as a string. So it's good to know how to convert that string into the numeric type, either a double or an int. And this is how you do that. So that's just a little aside. So again, here in my driver program, I have the user enter in the title, price, and duration because no matter what kind of audio item it is, it's described by those three pieces of information. Then I declare my audio item variable. I'm just calling it item, but I don't initialize it. I just declare it. So the declared type of item is audio item. Okay? And now I ask my user, okay, hey, tell me what kind of item you want to create. Enter M if you want to make a music item, and B if you want to make a book item. And then if they enter in M, I ask them to tell me the artist and the genre. I read that in, and then I create an object of type audio music item. So here the actual type of item is audio music item. But if on the other hand the user typed in B, then I ask them to tell me the author and the number of chapters, and I create the object with the audio book item constructor, and now the actual type of item in the else case is audio book item. Once I create my object, I'm just going to print it out and I'm going to invoke the playSample method. Now note that at compile time I have no idea the actual type of item because it totally depends on what the user enters in. If the user enters in M, it's going to be a music item, and if the user enters in B, it's going to be a book item. And at compile time, I have no way of knowing. But I don't care. The compiler does not care about the actual type. All the compiler cares about is the declared type. And the methods that I'm invoking here, I'm kind of invoking behind the scenes the toString, and here I'm invoking playSample. Both of those methods exist in audio item. So toString and playSample both exist in audio item, so the compiler is happy and I'm allowed to invoke these methods. I get no compiler errors. But at runtime, the JVM will figure out, well, which play sample should I invoke? Should I invoke the one in audio book or audio music? And it'll use the actual type to figure that out. So let's go ahead and run this. So enter the title, and I'm going to start with my music, Rainbow Connection. The price, 99 cents. The number of seconds, 180. And now it's going to say, okay, is this a music item or a book item? And I'm going to say this is a music item. So it says, okay, give me the artist, Kermit, and give me the genre. I'll call it folk. And then it prints it out. The title, the price, the duration. It also prints out the artist and the genre because that's the audio music item version of the toString method. And then it says that it's sampling 30 seconds out of my full duration, again, because that's the audio music item version of play sample. Remember, the music version played 30 seconds. So because the user chose to create a music item, these two methods, the toString and the play sample, were invoked from the music class. If I run this again with a book information, again, I enter in the title and the price. And I don't know, we use some really long number for that. And now I'm saying, well, this is actually a book. So the author is, Deedle. And the number of chapters it has, I don't know, 24. And now it's going to output the toString version taken from audio book and invoke the play sample method, again, taken from audio book. So at runtime, the JVM figures out, well, what's the real type of this? And at runtime, it'll know because it just created it either in the if branch or in the else branch. So at runtime, the JVM figures out the actual type and invokes the play sample method from that class, the class of the actual type. So again, both pieces of information are important. The declared type matters because you're only allowed to invoke methods if they exist in the class of the declared type. But the actual type matters because that's the version of the method that we're really going to call when we actually run the code.